Okay, radioactive pollution and energy. So there's a couple different ones we can talk about. You've probably heard these, or we've mentioned them before. You have your alpha and beta particles, and then you have gamma rays, which is just pure energy. And then you have half-life. How long do these things stick around? Not the whole thing going away, but every time period, whatever that half-life time period happens to be, half of that substance will decay, and then given that time period again, another half will decay, and it'll keep going and going and going. Next one on here is we're going to see some of the little annotations that I've made here. You have all this energy which comes from the sun. All of our energy, well, the vast majority of it comes from our sun. Now, in regards to radio waves, no, these are not like your favorite radio station, but it is that energy that does come. Looking over to the left here, we can see all of these X-rays, gamma rays, cosmic. These are knocked out by the atmosphere, things that we would find up in the stratosphere, ozone and such. They knock out these very high energy, low frequency waves, so we don't have to worry about them. The ones we really have to worry about are, well, for the most part, is the ultraviolets on down. But this is a nice little pictorial of all of our energy. A couple of laws. Thermodynamics. First one, energy cannot be created or destroyed. We've talked about that before in the past. So all energy comes from other energy. Forget about nuclear stuff in chemical reactions. The next one is entropy. That as energy moves through a system, it becomes lower quality in each step. So the efficiency drops every step of the way. Nice example is you have gasoline you put in your car. It's a chemical energy. And as you transfer that chemical energy into mechanical or kinetic energy, it is downgraded. A lot of that energy is lost, entropy. Some of that energy is lost to the environment. And here we have a nice little picture of kind of the transfer or the flow of energy, thermal energy. So obviously the ultimate source we have here is the sun, and it's transferring over into chemical energy, photosynthesis, and then that in turn turns into food. And then of course we have this guy here using that energy up, eating an apple and doing some work. Notice for every one of these stages, some of that heat energy is being lost as waste heat. So some of that energy is moving on every single step. So efficiency is lost in every stage. This little pictorial here just kind of shows the comparison between energy and matter as it moves through the system and how there can be differences in how that energy is used. So they're kind of saying this is unsustainable. The idea is we actually would shrink this diamond down and therefore be a more sustainable approach. And therefore you would have, at the end, you're always going to have low quality energy and waste, but just trying to minimize the amount of waste along the way that is not being used for our intended purpose, so we have more efficiency. And here's another little pictorial showing the same idea as energy is cycled through. So the main thing we're looking at here is how do we kind of minimize these parts along the way. Therefore, we're getting more product and less waste at the end. So we have ultimately we are going to use up these substances and have waste in energy, heat, and pollution. But how do we get the most use out of the materials and the energy along the way? So that's it. That's the end of the lecture. Second part, done.